So yeah, my name is Giese. I'm a field services and a software engineer at RT-Brick. And before I joined RT-Brick almost 3 years ago, I worked 7 years for Juniper Networks. But my journey in network engineering actually started more than 15 years ago at Deutsche Telekom AG. So first slide, please. Okay. Today, I'm very happy to talk about one of my favorite open source projects, which is the BNG Blaster. But before I go into the details, let me explain what we do here at RT-Brick and why we decided to build a complete new open source network test software from scratch. So here at RT-Brick, we build carrier-grade software for off-the-shelf bare metal switches. RT-Brick full stack software takes advantage of the latest American silicon, like the Broadcom Q2C, to give you high performance at a fraction of cost of conventional router systems. And of course, being a network vendor means that we have to do enormous testing, network testing, protocol testing, scaling testing, and all this stuff. And this is where the BNG Blaster comes into. So next slide, please. But why do we build our own network tester? So first of all, there was no open source alternative we could find on the market. And scripting around Linux PPP or SCAPy and other frameworks, this did not scale and even did not work well for us. But what about a commercial network test software? Of course, we started at RT-Brick with a commercial network test suite, and we still use them for some test cases, so special test cases, manual testing, and even for protocols which are still not supported on the BNG Blaster, like OSPF, an example. But we reduced this to an absolutely minimum. And one of the reasons here is that some of the features we need for our testing, they are still missing. And others, they are supported on their hardware platforms only. And especially these hardware test platforms, they come with enormous costs. Okay. And even the virtual platforms, which is what we use here at RT-Brick, they have a large resource footprint. And another issue is automation. Of course, all the commercial network test software, they have a lot of automation possibilities. They have REST APIs, they have robot keyboards and all this stuff. But it doesn't suit it very well for our use cases. So we run a lot of tests every night. So we have some daily builds, and then overnight we run a lot of regression tests. We have multiple pipelines for different platforms, like virtual platform, Broadcom QMX, Q2C, and all this stuff. And for every platform, we run PPPoE, IPOE, BGP, ISS. We run hundreds or even thousands of tests in series. So we needed a platform we could spawn up in seconds, not something we need to reserve an instance and need to initialize the ports, wait, then it takes a few minutes before we can set up the first sessions and all this stuff. And of course, something we can easily scale out to the maximum of resources we have without paying licenses for every port we use overnight. Because on average, we may need 10 ports, but in the night hours, we may need hundreds of ports. But then we would need to buy 100 licenses. And last but not least, there was a huge administrative overhead for these platforms. There are license servers, ports, sometimes the reservation hangs, so the admin teams has to go on to clear the reservation and all this stuff. So next slide, please. So therefore, in July 2020, we started with the BNG Blaster as an internal project. And this was actually caused by IPTV. So we added IPTV support to our BNG platform, which means actually IGMP, but with some special requirements for IPTV users. And one of the major things to test here is the IGMP join and leave delay time. And this wasn't supported on the virtual platform of our test suite. So we have to decide to do an enormous investment into a hardware platform or to try something on our own. And of course, we have done secondly. So we tried ourselves. And I guess after 2 weeks, the first prototype was quite working. And we have seen the first PPPoE sessions up and running and IGMP joins sent to the device. We could measure the join delay here. Then we added traffic generators and all the stuff. And this was working so well that we further invested into this project. We added more and more features. We changed our internal testing from this test platform to the BNG Blaster. And in February 2021, we published this the BNG Blaster on GitHub as a BSD free licensed software, which gives you also the freedom and the possibilities you need to maybe modify and use it in whatever you like. And then, after the publish in 2021, we added more and more features like L2TP, IPOE, A10NSP interfaces, TCP, and recently we added the first routing protocols. So we started as an access tester, and now we improved this to a complete end-to-end router tester. And first protocols are ICS and multi-protocol BGP here. But we will not stop. So we still have more and more plans, more protocols, DPDK, TCP streams, and all the stuff. And this is a project which is continuously improved and actively maintained by RTBrick. But it's a community project, which means we are happy about any contribution from the community, feature requests, code contributions, or just some hints or issues. So every kind of input or contribution is welcome. So we spent around about 2 years of work here, but not full time. So it was a project we have done, let's say, with our engineering team. So mostly it's done by myself as a half-time project. So with more than 600 commits in the last 2 years, and it's around about 30,000 lines of C code. So next slide, please. So what we have already achieved with the BNG Blaster. So today you can emulate massive PPPoE or IPoE or even BGP sessions with a low CPU and memory footprint. Actually, there is no hard limit on how many sessions you can emulate, but it's mostly driven by the single thread performance of your CPU. And I say single thread performance because all the protocol state machines run in the main thread. So therefore, if you would like to scale as much as possible on a session base, you need you should prefer a CPU which has a high single thread performance, which is also the reason because why on my testable system I use a Ryzen 7 desktop PC for development. I can get better numbers compared to our servers in the network in our data center because I have the better single thread performance here. But we already started to delegate a few tasks into separate threads. So we already have some TX threads so that the traffic generator can send traffic in dedicated threads, and we further improve this here. So then it runs on every modern Linux. So it's a prepackaged for Ubuntu, but there's also support for, it should run on every Linux system. And there's also support for NixOS there. And then it runs on virtual machines, containers. This is what we do. We run the BNG Blaster in containers. And we even run it on a lot of tests on read interfaces because it gives us a lot of flexibility to connect to the device under test, very flexible. And for most of the tests, we don't need a lot of throughput. So we just need some control plane traffic. This is the strength of this project because it runs on nearly any environment. And if you need to scale beyond a lot of traffic, then you can even connect to the interfaces directly. But most of the tests, you run with a low PPS. Then all the protocols implemented are completely implemented in user space from scratch. So Ethernet, IP, UDP, all the stuff we implemented completely new from scratch, even ARP and all this. And there's only one exception, which is TCP, where we use LWIP, which is a lightweight TCP user space framework. The BNG Blaster has an automation-friendly JSON RPC API and supports a lot of access and routing protocols. So for access, we are able to emulate PPPoE and IPoE clients. So the half of the world runs the BNGs with PPPoE and the other half of the world uses IPoE, which is actually just plain IP with DHCPv4 and DHCPv6. There's support for dual stack IPv4, IPv6, delegated prefixes via DHCPv6 for PPPoE and IPoE. Then there's a very unique feature, which is the L2TP v2 LNS emulation, which is relevant for the PPPoE customers. So we can emulate the LNSs, and we have a lot of configuration options to emulate different flavors. So you can configure the BNG Blaster to behave more like a Cisco LNS or like let's say like a Juniper LNS, these kind of things. So you can test all the permutations and issues to see. Because sometimes you have issues where you say, okay, HTTP works with Cisco, but doesn't work with Juniper, and or vice versa. So you can emulate all these different behaviors. And it even supports RC5515 with CSUN and CSOC, which is something which is otherwise very difficult to test. But this is in general a thing. The BNG Blaster has a lot of features here, which allows you to change the behavior of the protocol. Even some knobs to behave not RFC conform. Because you have to assume, let's say I have a million CPEs in the market, and they don't behave correctly. But I cannot say to the customer, yeah, it works on the old BNG, but not on the new platform. So I have to accept this wrong behavior. So then I would like to have a test tool which can even emulate a wrong behavior and see if we can make it working. And here we have a lot of config options to let's say mimic the different behaviors of the different CPEs in the market. We can emulate an A10 NSP interface, which is required for layer 2 bitstream access testing. And then there's, as mentioned before, the multicast IPTV test suite. I will go into a few details later. And we can even verify legal interception traffic, which is important for a BNG. Today we support the Broadcom shim header only, but we can easily extend this, let's say, to support JMirror header or other headers here, which are used in the LI space. We added the first two routing protocols recently, which is ISAS with segment routing and multi-protocol BGP with thousands of sessions or even millions of prefixes. The BNG Blaster is also able to send and receive MPLS traffic with up to 2 MPLS labels. And there is a built-in traffic generator, and which is able to generate and track millions of traffic flows. And if I would say generate and track, which really means that, let's say if you configure 1 million traffic flows, and this is what we very often do for a full table test, you can get a report, a very large JSON report with details about every single flow. So for every single flow, it shows you how many loss we have received, the min and max latency, what is the MPLS labels received, what is the EXP bit for every label, the TOS bits, and all the stuff. And then you get with 1 million flows, you get a 500 megabyte JSON file. But luckily, the Python JSON library is written in C, so you can easily iterate over your reports and generate diagrams, graphs, and reports as you like. So you can use the traffic generator to verify your cross configuration, to verify forwarding states, or you can even use it to measure conversion times or traffic loss. So next slide, please. So what can you do with the BNG Blaster? Yeah, that's fine. No, it's fine. The next slide. So I will give a few examples here about what you can do. And one of the first use cases of the BNG Blaster is PPPoE scaling. Here in this example, I set up 8,000 PPPoE sessions. And the first thing you can see is that the BNG Blaster has an optional N-curses user interface. So, which was also quite handy. So if you do manual testing, not automated testing, this user interface is quite handy because you have on the right side your log viewer, on the left side you have some stats and progress bars, which makes your testing quite comfortable. And because it's N-curses, you can run it over an SSH session without any kind of port tunneling for HTTP or other stuff, just SSH to your test device, start the Blaster, and you can remotely test. And what you can also see here is that we have these progress bars, which shows you how many sessions we have set up. And there's also a progress bar, which you can see in the middle, or the last of the 3 progress bars, which is called traffic flows verified. And this is referring to session traffic. And session traffic is a very powerful feature here in the BNG Blaster because it allows you to automatically generate traffic for every learned IP address. So let's assume we have a PPPoE session set up with dual stack IPv4, IPv6, and a delegated IPv6 prefix. So we have 3 IP addresses learned. So we need 6 flows up and downstream to test and verify if forwarding is working. So you can configure session traffic, and then the BNG Blaster automatically generates traffic flows for all the dynamically learned IP addresses. And and can then verify the traffic. So you can see on a single picture if control plane and data plane is converged and working. So next slide, please. Then we have IPTV test. So here, the most interesting part is zapping. So we can configure a zapping profile, which is typically something like change every multicast channel every 5 seconds. And then after 10 channel changes, remain for 30 seconds, and then again change. And then we can configure hundreds or 1,000 sessions, doing this in parallel, but with a different starting point to have a bit more random. And then we can measure the leave and join delay. And we can even configure a max join delay, because most of the IPTV platforms, they say we allow maximum 120 milliseconds join delay. So then we can count how often we raised the maximum value here. And we can also measure if there's an overlap, which means if you step from channel A to B, the expectation is that in the IPTV world, that you do not receive traffic from channel A as soon as the first packet of B is received. Otherwise, you receive 2 channels in parallel for a short time, which may lead then into pixels on the customer screen. So this is also something you can easily verify here with the BNG Blaster. Next slide, please. Then very interesting, and maybe more interesting for the most of the audience here, is a BGP setup and teardown testing. And here in this example, I set up 4 BGP sessions, 2 IPv4 and 2 IPv6. And you can easily or have just one session with multiple NLIs. But in this setup, I just used a dedicated session for each NLI, but it's not a limitation here. And in IPv4, I send 800,000 prefixes. So a full table, you can say. In IPv6, I send 200,000 prefixes. And half of the IPv6 prefixes, they are labeled with the implicit null label 2 to emulate, let's say, a Juniper router. And the other half is sent with random labels to emulate a Cisco router. And then you can see in the log that after 5 seconds, all these 1 million prefixes, or actually twice, so 2 million prefixes are learned after 5 seconds. But you all know that this doesn't mean that they are now working. Can you go to the next slide? And therefore, we set up 1 million traffic flows. And then we can see on the traffic flows results how fast the forwarding is installed, as well as how long the forwarding still works after the session goes down. And then we can craft the JSON report to generate diagrams like this one here. So here you can see in the test before that we have, it took 200 seconds to install the 1 million prefixes into the ship, and it took about 100 seconds to remove them from the ship. And this is important for us to verify constantly that we can improve here this curve. But it's also maybe interesting for you to verify maybe the impact of a configured BGP policy on the convergence time, or if you do a POC in the vendor selection, what is the better BGP software, and so on. Next slide, please. Then we have ISRS. For ISRS, there is also a tool called LSPGen. LSPGen allows you to generate in topology. So you can say generate a random topology with, in this example, 10,000 nodes. I know it's huge, but it's also called BNG Blaster. So here I generate with a single command a 10,000 nodes topology with 20,000 links. And then I can export this in an MRT file, and the BNG Blaster can then advertise this topology via ISRS. But the BNG Blaster behaves also like a real ISRS router. So it is flooding learned addresses and all this stuff. And even what a cool feature here is that as soon as you stop your test, the BNG Blaster automatically generates purge LSPs, so that after the test has stopped, the LSP database in your device under test or in your network under test is empty, so that you can restart the test again and again. So next. So how to start with the BNG Blaster? So I hope it is an interesting project for you. And if you are now interested, then you can go to rtbrick.github.io/BNG Blaster. And there I added a quick start guide. And this quick start guide was built in a way that you can run all these examples without having your own network equipment or lab devices. So there are 3 examples: PPPoE, ISRS, and L2 and BGP. And then you can just go through the steps, and then it shows you how to install the BNG Blaster, how to use the API, how to use the different features, the configuration. So you just need an Ubuntu VM and then go through the step by step. Next. Yeah, who is using the BNG Blaster? The BNG Blaster is already used by some leading network operators and hardware and network software vendors. So here a few who give me the permission to name them here. So of course it's ourselves. And then there is the Deutsche Telekom AG with their famous Access for the Zero project, as well as Ting Fiber, which is a fiber internet service provider. Next. So what is the roadmap? So as I mentioned before, we still add more and more features. So very soon we will publish the BNG Blaster Controller, which is a single Go binary, which allows you to start, stop, and interact with the BNG Blaster using a REST API. And we also have the corresponding robot keywords here. So this is important for you to automate your stuff. So this is also the tool we use for our automation, but we still didn't find to automate until now. So this is something I have on my to-do list. Then BGP authentication. Today, BGP is not the authentication support, but I will add in the next days or weeks and authentication support here for MD5 and TCP AO. And we would like to increase the scaling. So actually, there is no scaling limit for BGP, but LWIP uses, this is the TCP library we use. It uses a linked list to store all the TCP sessions, which means for every TCP packet, it iterates over this linked list to find the correct session. And this doesn't scale, it's not optimum for this amount of session scaling. So we will replace this with a kind of hash map, and then we can also increase the scaling. And this will also go hand in hand with the next requirement we plan, which is TCP traffic streams. Today, all the traffic streams are UDP, but we plan to add support to configure or generate TCP traffic streams, and even with the target of 1 million streams. And this is interesting for the carrier-grade NAT testing, because let's assume you buy BNG with 32,000 PPPoE sessions and carrier-grade NAT. And then they say typically, yeah, we support 1 million TCP streams in NAT, but yeah, how to verify this? And then here the idea is, okay, you can then emulate your subscribers and attach then the TCP traffic to verify that your BNG is able to handle this 1 million TCP sessions. Then we play with DPDK and XDP to increase the throughput to something beyond 10 million PPS. This is also something you will possibly see very soon here. And we will constantly add more and more features, protocols, LLDP, BFD, PIM, RCP, OSPF. The next slide, please. So last but not least, for this project is the community project. So we also want you here. So we are very happy about any kind of contribution to the project. So it doesn't matter if it's, let's say, a feature, some code contributions, or even just documentation, or if you open enhancement requests, or just share your experience, or some tools or scripts you built around the BNG Blaster. We are happy for all the contributions here. So then we can go to the last slide, which are the questions. And I hope I'm in time.
Thank you, Christian. Are there any questions in the room? No? Any remote questions? No, okay, no remote questions. I'll just give it a minute for remote questions to come in, and I will once again abuse my position. Oh, there's a question in the room. Yeah, can you come up to the microphone so everyone can hear, please?
Hi, you mentioned the lack of other open source traffic generators. Cisco T-Rex, I was just curious whether you'd evaluated that and whether it would have been suitable or expandable to meet your use case.
Yeah, we also used T-Rex before, but the problem here was it was not well suited to integrate this massive amount of finite state machines here. So T-Rex is a great traffic generator, but the BNG Blaster here was more optimized for emulating sessions and then add traffic on top of these sessions. And this kind of dynamic traffic and session handling was difficult to integrate in T-Rex. But we also use T-Rex for our testing. As I said, it's a great tool, but it's not optimized for this massive amount of finite state machine handling.
Okay, great. Thank you.
And I'll just ask a question while I'm standing here. Christian, you mentioned that so you've got the interactive CLI for doing manual-based testing, and you've got a JSON API as well. Do you support any sort of scripting as well, like Lua scripting?
No, but you can easily, we have a lot of customers using their own Python scripts using the JSON RPC API. So it's super simple to use this. It's just sending a JSON request, you get a JSON response, and then you can automate this. But as soon as the BNG Blaster controller is out, or some other customers build their own controllers, you just interact with the API. So there's this JSON API or a REST API, and then you can script around this. So this works. And adding a new command or API endpoint is quite simple. So if there's a feature request, most of the commands we can add in a few hours. So it's well modeled, the code, so that we can add new commands quickly.
Oh, cool. Thank you very much. Did any remote questions come in, Kathy? No? Okay, this is the end of the questions. So thank you very much, Christian.